just a little bit. Now, simple harmonic motion. We're not going to get into all that sine, cosine, the acceleration, the velocity, and all that kind of stuff of an object coming. We're just going to look at a simple object in a pendulum type thing for the exam. Okay, so here you go. You got, see how it's bobbing up and down? It'll start going slower, but actually the period stays the same. It's just not going as far, and the frequency stays the same. Okay, as it bobs up and down. Well, I mean, there's a lot of energy loss in the dampening of it. Another funny thing about dropping, if you've seen that in slow motion, it's really kind of cool. I mean, if you put this on really slow motion, when you drop a slinky, it like seems to hang in the air until it's all collapsed together, then it falls. But you can't, in real time, it's kind of hard to see, or I need a lot bigger slinky. All right, anyway, so let me get my mug off the camera here. Yeah, so period and frequency and oscillations, pretty straightforward, real straightforward stuff. And then, but then when we look at how they go up and down, when it's actually moving, we get this. Okay, so we know that the frequency is 1 over the period. And the period is how long it makes one oscillation. It goes forward, out and back, or up and down, up and down. Okay, so that's the period, the time it takes to do the period, and this is measured in hertz. Okay, and so the period then is equal to 1 over the frequency. Hertz is also measured in negative seconds, and the period is measured in seconds. All right. Now, here's the thing. When we have an oscillator, as they show here, simple harmonic motion. We're going to look at all this stuff. Here it is, period of a simple harmonic oscillator. And that's what I was showing you with the slinky. The period, t equals, and then the inverse of that is that. So let me write those down. I'll talk about them real quick. 2 pi square root of m over k. And the frequency is equal to 1 over 2 pi times the square root of k over m. It's just the flip-flop of it. All right, so there they are, written out. Okay, now then, what does that mean? That means if I put more of a mass on this spring, on this oscillator, if the mass is bigger, that means the period's going to get larger and the frequency is going to get smaller. Okay, because if it takes longer to make a trip, then that means it's going to make fewer trips. Frequency is the number of trips it makes back and forth. It's the number of trips it makes back and forth in a second. And the period is how long it takes to make a trip. All right. So, and so if the mass gets massive here, then the frequency is going to get really small. If the mass gets really, really small, if you make the mass really small, then it's got a lot of, goes back and forth really fast. And so that means the period is much shorter. All right. And then that gets us into the good old, my favorite thing, the good old, don't look at all this stuff. It'll make your head hurt. Here we go, the simple pendulum. Okay, so now, but I do want to talk real quickly in the simple pendulum. We're not going to make you derive it or anything. Here's the formula for it. And so the period of the frequency of a simple pendulum would just be the inverse of that. All right? So for a simple pendulum, there's something I wanted to tell you extra about the pendulum. So the period of a simple pendulum, now notice it's 2 pi divided by the length of the pendulum divided by g. All right? So let's say Spock is on planet whatever, planet X, okay, with Marvin the Martian, my coffee mug here in the office. All right, he's on planet X. Now he wants to know what the pull of gravity is on planet X. All right, so he gets a pendulum going, and he measures that pendulum. He goes, okay, well, this pendulum that I have going, he's going to let it make 30 oscillations and it takes 45 seconds, and for it to do the 30 times back and forth, it took the time to do those 30 oscillations. Let's say it took 75 seconds. Guess what you have here? You have a frequency. What's the frequency of this pendulum? Well, what do you need? You need seconds in the denominator, right? So the frequency is going to equal 30 oscillations back and forth divided by 75 seconds. Aha! Then I'm going to get the number of trips per second. 30 of them in 75 seconds. Take 30 divided by 75. I should have made it 60 just so we get 0.5. 30 divided by 75 is equal to 0.4 hertz. And so the period then is equal to 1 over that, which is 2.5 seconds. So each period took 2.5 seconds. If length is known, if Spock knew what the length of that thing was, could he figure out what the gravity is on the planet? I think so. I think he's got that. All right. So there you got like 3 or 4 types of problems that you need to study. Those are what you need to look at in chapter 16. All right. I'm just going to tell you. Okay. All right. Let's go on to the next one. Let's go underwater. Let's look at pressure because you're all